Hi, Assalamualaikum. This is the case study video of our group named Gadis Material. In this video, we will learn about nanotechnology in cosmetics. So, what is nanotechnology? Nanotechnology is a cutting-edge branch of science that involves the design, characterization, manufacturing, and application of materials, device, and system at the nanometer scale, which is 1 to 100 nanometer. Nanotechnology has been used in many fields of science, from electronics to medicine, and has now found applications in cosmetics under the name nanocosmetics. Nanotechnology incorporation in a cosmetic formulation is regarded as the most recent and emerging technology. Nanoscale ingredients are used by cosmetic manufacturers to provide better UV protection, deeper skin penetration, long-lasting effects, increased color, finish quality, and many other benefits. In fact, Lancome and Dior introduced the first nanotechnology-based cosmetic products in 1986, dubbed Neosome and Capture respectively. Okay, but first, let's take a look at the video. Just so you know, nanoparticles can be incorporated into creams, lotions, gels, and shampoos, resulting in products with an excellent sensorial. The size of invent sphere can be around 100 to 200 nanometer. The encapsulated actives are protected from light, oxygen, and other components of the formulation. Nanoparticles form a thin film on the skin, preventing excessive water loss. Because of the occlusive effect, the skin moisturizing effect is greater. Nanoparticles are not comedogenic. Nanoparticles are deposited into the stratum corneum, allowing the active permeation to the deeper layers of the epidermis. The active permeation is low and continuous, allowing a greater efficacy and reducing possible skin irritation. The encapsulation of the actives in nanoparticles allows to reduction of systematic absorption, reducing possible side effects. The nanoparticles also are biodegradable. Thus, formulations containing encapsulated actives in nanoparticles provides more effective and safer cosmetics than conventional ones. The following are the types of nanomaterials used in cosmetics. Next, I will explain about the role of nanoparticles in overcoming the barrier properties of the skin. This diagram shows the properties of the skin barrier. There are three mechanisms mentioned for other compounds have been seen for nanoparticles to penetrate skin, such as transcellular, intercellular, and appendageal route. In this process, nanoparticle size is very important. The large follicular area also permits the formation of nano-objects that can be dispersed in sweat, and the chemical physical characteristics of the skin surface influence how quickly nanoparticles penetrate, or they might prolong the time that these systems are available in the stratum corneum. Despite the fact that nanoparticles differ in the capacity to penetrate depending on their size, composition, and colloidal stability and vehicle qualities, the first group is made up of polymeric nanocomplexes that remain biopersistent after being applied to the skin, and solid inorganic nanoparticles. Lipid and surfactant-based nanoparticles used topically are not completely understood to have a specific destiny. Once they have been injected, it is exceedingly difficult or perhaps impossible to distinguish between these nanoparticles and the skin constituents due to how similar their compositions are. However, it is generally accepted that these nanoparticles are destroyed once they pass through the epithelium, and that flexible particles penetrate deeper than rigid nanoparticles. However, nanotechnology in cosmetics also has their own challenges. Due to their small size, nanoparticles can readily into the bloodstream through the skin or inhalation, where they will be delivered to numerous organs. The nanoparticles' high dosage and extensive residence time in important organs might cause them to malfunction. Nanoparticles are produced in a variety of shapes like spheres, tubes, and etc., and this may be a major cause for the health risks caused by them. A study has shown that exposing the abdominal cavity of mice to long carbon nanotubes are linked with inflammation of the abdominal wall. Nanomaterials are also extremely reactive due to their high surface area to mass ratio, which provides greater surface area per unit of weight for chemical reactions. Some nanoparticles may be potentially explosive as a result of this heightened reactivity, according to studies. Nanoparticles have been proven to penetrate skin in scientific experiments, particularly when the skin is flexed. Acne, eczema, and wounds can increase nanoparticle absorption into the bloodstream, which can lead to more issues. Other than that, cellular toxicity of zinc oxide and titanium dioxide nanoparticles. The action of dissolved zinc ions in the culture media or inside cells was discovered to be the cause of zinc oxide nanoparticle toxicity. Meanwhile, the researchers also discovered that titanium dioxide-based nanofilaments were cytotoxic, which was influenced by their geometry and exacerbated by the presence of flaws in the nanofilament surface caused by chemical treatment. Internalization of nanofilaments and changes in cell morphology were detected. Last but not least, workers may be exposed to nanoparticles by accident during manufacture of nanomaterials or products containing them, as well as during their usage, disposal, or recycling. Next, I will explain about the application of nanotechnology for cosmetics. For instance, sunscreen that use zinc oxide nanoparticles to block ultraviolet rays while minimizing the white coating on the skin. Other than that, sunscreen that use nanoparticles generated by IV plants, research has shown that these IV nanoparticles are more effective than outside nanoparticles in blocking ultraviolet rays. Also, skin creams that use protein derived from stem cells to prevent aging of the skin. These proteins are encapsulated in liposome nanoparticles which merge with the membranes of skin cells to allow delivery of the protein. Skincare lotions in which nutrients are encapsulated in nanoparticles suspended in the liquid, making up a nanoemulsion. The small size of the nanoparticles compared to particles in conventional emulsions allows the nanoparticles to penetrate deeper into the skin, delivering the nutrients to more layers of the skin cells. Lotions that use titanium dioxide nanoparticles called ethosomes to deliver nutrients that promote hair growth. That's all from us. Thank you from Gadis Material.
Gadis Material!